Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is part 8, I think, of this series of streams in which I am developing an open source application in JavaScript that allows you to draw on top of your screen. So if you have a tablet like this, and you are an educator or you are presenting something and you want to draw on top of your screen, this app called Notestrator will allow you to do just that. And yesterday we started addressing an issue in the app that has to do with when you draw too fast, the JavaScript events don't fire often enough to capture so many points that the curve will be smooth. So if you're drawing too fast, the lines look like a bunch of straight lines, which is what they are. And we started to implement this algorithm that will create a curve, so-called cubic Bezier curves. So it will draw curves between the points to smooth out the drawing. So that's where we are. Let's jump into the code base as we left yesterday, and I will run it real quick. So as of now, you are able to connect your tablet to your computer, and there is this canvas on top of the whole screen. It's transparent, but it's there, and you can tell because there is an Electron app running. And then you can start drawing on top of the screen, and that part works. It even draws on top of the menu bar, and it draws on top of full screen apps, I think. Let's try this. This is something that I think we got working, but I'm not 100% sure. So if I have a Safari window that is full screen, oh, we are not able to draw on top of that. Oh, that's unfortunate. But we are able to draw over multiple spaces. So I guess the only way to show this is to have another space. And I'm bringing out these points because they are things that don't work in the competition. So we looked at some other apps that try to solve the same problem when we started this project, I think last Monday. So Monday last week, not this week. And they were not able to draw on top of the menu bar, and I haven't tried, but I don't think that they were able to draw on top of every screen. And that's something that our app is already doing. But check out, if I draw something very fast, how you can see the segments. That's what we are working on. And you may be wondering, what is this about? Well, that is a demonstration of the algorithm. So yesterday we developed this algorithm that, given 3 consecutive points, it will calculate the so-called control points, these purple points. Hang on, let me get my eraser. We have implemented that last week, I think, last Friday. So you have the curve, and in JavaScript, the only thing we get are these points, because they are the points that were collected on the onMouseMove event. And what we did yesterday was to implement this algorithm that, given the 3 points in a row, it will compute these so-called control points of a Bezier curve. And the control points will be positioned such that the curve is smooth. As you can see, it is not pointy at any point. It is a smooth curve in red. And I find it so entertaining that I can use the app that we are developing in order to explain the development. I find that fascinating. So we did the algorithm for 3 points in a row, but when you are drawing on top of your screen, you will have hundreds of points. So we need to change this this algorithm so that it applies to all the points. And maybe we will have time to do something else today, but we'll see. We'll start with humble ambitions. By the way, on a different note, I got this backdrop. What do you think about it? Do you like the backdrop, or do you prefer the previous streams in which I was just in a bedroom, in a space? I like the backdrop. Do you like the backdrop? Let me know. Okay, so how are we going to do this? Well, we are collecting points on mouse move. So my idea here is we could, when we collect the point, we don't add it to a polyline. We calculate the control points and put a new Bezier curve on a path. So let me explain what's going on here. The existing implementation, the one that draws a bunch of line segments, is based on this SVG element called a polyline. And we start the polyline when you click, or equivalently when you put the pen on the tablet. That fires an on-click event. And then when you move the cursor, so this function, when you move the mouse around, it will add points to the polyline. Now, my idea here for our strategy is pretty much the same as this, except that we will not be using a polyline, and we will be not just adding points to the polyline. Instead, we will be using this other SVG object called a path, and we will compute the so-called control points that will make the curve smooth. So that's the plan. But there is an off by one problem here. And the problem is, to compute the control points, we need 3 points in a row. But when we are doing the on mouse move thing, we have access only to the latest point. And to begin with, there is only 1 point. When you put your cursor down, when you press the mouse, there is only a single point. So we'll have to handle this case in some way. And I think that the simplest way would be just to add some extra points in the beginning. We'll see how this goes. So let's begin by changing a polyline and making it and turning it into a path. So the path does not expect a points argument, it expects D, which I guess stands for like the description of the path. And then the first thing you always have to do is to move your cursor to a certain place. So this D parameter is not just a point or a sequence of points. It is commands. So you have to tell what you want the SVG to do. In my case, I want it to move the cursor to a certain position so that it can start drawing. So we'll move the cursor there. And maybe that's all we need to do for this part. The fill stays the same, the stroke, so the line properties will remain the same. And then on mouse move, we don't want to update the points field, we change that to a D field. And to begin with, how about we just add a straight line? So this will be equivalent to the polyline in Spirit. L is the command to draw a line, I think. So just by doing this, we changed the polyline into a path, but I think that it will behave the same. Alright, and it does. And just to check, does the problem still remain? Yeah, if I draw too fast, then it cannot collect multiple points, enough points. But if I draw, by the way, if I draw slowly, then it is mostly fine. I mean, it's still kind of aliased. You can see some staircases here, but it's not bad. I mean, this part is very acceptable. But that's not usually how we draw, right? Usually we are drawing things like this, and then you do a circle, and then the circle is like square-ish. So, yeah. Okay, so we are able to draw lines. But that's not what we are interested in. We are interested in computing Bezier curves. To do that, we are going to need 3 points. One of the points is our current point. but we need the two previous points. Now, the two previous points are here in the D path, and we could try to parse this information out of the D path. But I think that's a bad idea, because to parse this string, necessarily we will have to do some string manipulation. Maybe using a regular expression, maybe using string functions. I don't know, but we will have to manipulate strings, and this will be, I think, somewhat slower and maybe even more confusing to implement. This parsing algorithm for the current D path could be kind of confusing, because we would need to look at the previous points and try to parse them, and we are sort of doing that for the eraser over here, but we were doing that with polylines, which were easier to parse. And that by the way is another issue. We will have to change the eraser because it expects a bunch of points, but now it needs to check for the points in the Bezier curve. But that's for the future. Let's try to make this work first. So we could parse the information. The information will be hidden in there somehow. But because mouse move is such an important event that needs to happen fast, it's the thing that determines whether the curve will be will have enough points to even, I mean, it will be smooth because we are implementing the smoothing algorithm, but the question remains, if you have enough points, then the curve will resemble the thing you wanted to draw. But if you don't have enough points, then the curve will be just off. So I want this handle mouse move to be as fast as possible, and I don't want to parse this string. I mean, I do it on the eraser, but if the eraser does not compute enough points, it's kind of okay, because you will pass near enough of a point you want to delete. I think it's okay. I mean, it has been okay so far. We played with the eraser a moment ago. So instead of parsing this information from out of the D field, what I'm going to do instead is I will collect this information about the two previous points. So I have the current point, and I will collect the information about the two previous ones, and I will just keep them around. So how about we have the previous point, and I said that we had to do some work with the first point. So the first point does not have a previous point, and I suppose that it would be acceptable for us to do something like this, where we just say that the current point, to begin with, like in the first point, the current point, the previous point, the previous point, they are all the same point to begin with. I guess it will be fine, we'll see. So now let's change this to be X and Y, and then the previous point. These names are ridiculous, but I stand by them, yeah. So when you put the cursor down, we store these variables and we create the variables, and when you're moving the mouse, we have here in this function access to the previous point and the previous point. So how about we do some work, and then as the last thing we update. So the previous point, so now we're going to shift everything around. The previous point becomes the previous point. The previous point becomes the current point. And maybe it would be beneficial for us to have something like a current point that goes like this. And I'm doing it this way because I remember that when we implemented the algorithm, it made sense for us to have that sort of data structure with X and Y like that. I could just have variables called current point X, for instance. Doesn't really matter. So now we have access to the current point, the previous point, the previous point at this position. So now we need to compute the control points. And that's what we did yesterday. So let's borrow the implementation from up here. So I guess we will copy this whole thing. And we'll leave it there because it's working. So we'll leave it there for reference in case we change something and we introduce a bug. So the thing about the smoothness factor, for details about this algorithm, go watch the stream from yesterday. I'm just going to mention the things that are essential for what we are doing today. But this mathematics I will not explain, and this mathematics I will not explain. But the thing about the smoothness factor that we need to know is that the smoothness factor is kind of a knob that we may or may not want to present to the user. We are going to implement this, we'll see how it feels, and then we'll see smoothness factors that make sense, and then we will maybe provide those as options to the user. We'll see. So what we were calling x0 was, I guess it could be kind of nice to show the document that we implemented this from. Well, then I will be tempted to re-explain the things that I talked about yesterday. I'm not going to do that. So x0, you know what? I'm going to do it just because we need a translation between current points and this notation here. So let's do that. What is the easiest way for me to get a hold of that document? I mean, weirdly enough, I think that the easiest way is for me to go to my own channel and go to yesterday's stream. And here I am live. This is very meta. But on yesterday's stream, I linked this document that has a beautiful illustration of the algorithm. So this is the illustration that we are going to refer to. So let's say that we are drawing from left to right. It is symmetrical, so it doesn't really matter, but let's say that we are doing that. So if you're doing it from left to right, x0 is our previous point. So everywhere where I have x0, I will replace with previous point. Should I call this 2 points ago? Maybe, I don't know. Okay, x1 is our previous point. And I'm doing this slowly instead of doing just a global replace because I want to check if everything I'm replacing makes sense. But this is the previous point. And then finally, x2 is our current point. So let's go. Oh, something. Oh, no, I thought that something went wrong here, but it doesn't seem to have gone wrong. So that's our current point. And then we have P1 and P2. I'm going to call this control. Well, do I need to replace this in other places? No. So I'm going to call this P1. I'm going to call this the control point before previous point, right? So x1 is our previous point, and then P1 is the control point before the previous point, and P2 will be our control point after previous point. Bam. Oh, I renamed all the variables. No. So these names are getting ridiculous. Well, but for one thing, I know that the smoothness factors I want to keep, but these 3 points, no, they are these points over here. So I need to remove the previous point, the previous point, and the current point. And then we have some distance here. I will rename this variable. You know what? I don't want this renaming to affect the code that we wrote up here. So I'm going to comment out this part. It will remain there for our reference, but it will be out of the way. There you go. I don't think that the renaming refactoring Visual Studio Code would affect that variable, but just to be sure. So this is the distance between previous point and previous point. Look at this variable name. Distance between previous point and previous point. It couldn't be clearer. And this is the distance between the previous point and current point. This is the distance between previous point and current point through previous point. What? So this is the distance between previous point and current point going through x1, so going through the previous point. So it goes like this, bam, bam. That's what this variable is. And now, of course, this is the ratio between, I guess, between this, between what? Okay, so there is the distance between previous point and previous point, that is this line segment. And this is the ratio between this and the whole thing. Is this used more than once? Yes, it is. So it makes sense to have this as a variable. Okay. Ratio between distance, or I guess I could copy this variable name over, so this one. Usually I am all in for long descriptive variable names, but this is getting out of hand. The variable name is more than 80 characters long. Yeah, I think it's time for us to rethink this. How about we use these names, x0, x1, and x2? We can even leave so I had to go to the YouTube video for the stream to get a hold of this reference. But how about, instead of doing that, we leave this as we leave this reference as a comment here, and then we use the names used in this figure. That figure. So that is pretty much what we had above, but I will do it again. So current point, I wasn't too happy with these variable names anyway. So let's see. We have our current point, and previous point. Let's call previous point, let's call previous point. So I guess I'll do it in this order. Previous point is x0. Previous point is x1. And I really don't like how these are called x, even though x is one of our axes, but x is one of our axes. I'm having fun. Current point is x2. And then, well, I guess I could just say that x1 is x0 like this. No, I think I'll leave it like that because we may rethink this decision, right? It's incidental repetition here. And then over here we have x0 equals x1 and x1 equals x2. And here we have our smoothness factor, distance between previous point and blah blah blah. So this is x0 to x1. How do I like this variable name? I think I'll do it with underscores. It's kind of unusual, but I mean, it's kind of unusual for JavaScript, but given that this is kind of mathematics, it doesn't really matter. I think it's okay. And now the distance between the previous point and the current point is x1 to x2. and this is x0, x1, x2. So it goes from x0 to x1 and then to x2. And then the ratio between blah 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 and blah 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 is I'll call it ratio of x0, x1 in relation to the whole thing. And here is the ratio between x1, x2 in relation to the whole thing. Okay, this is now looking like the kind of code that a mathematician would write, right? Makes absolutely no sense. Yeah. Right. And the smoothness factor is called lowercase t. Scaling factor, that's what they call. But I thought they called that lowercase t. Yeah, they call it lowercase t. Do you want to go for that? Yeah, sure. Let's do it. So the smoothness factor will be t. I hate variable names like this. I hate code that reads like this. I guess in our case it makes sense. It's a fine balance. So this is P1 and this is P2. Okay, so we have computed P1 and P2 correctly, I think. I mean, I have not changed the code, I just changed the variable names. So this should be working, but we are not using P1 and P2, and there is a problem. We can only use... So let's talk about this problem. It's something that came up yesterday, but I think it's worth explaining this again. So the problem that we have here is that when we are working with the SVG, we have to draw one of these segments. But we have the handle for one side in one iteration of this computation and the handle for the other side on the next iteration of this. So we will need to carry this over. So how about we make P1 and P2 be this sort of global variables with respect to our algorithm. So we'll have P1 and P2, and to begin with, we will collapse P1 and P2 with the first point. So that's how we start all the points in the algorithm. We'll see if this works. And to update the path, we need to be careful about when we do it. It needs to be, so we are in this iteration of the algorithm, we are computing P1, so we want to use P2 that is a carryover, and we want to compute P1. So we want to compute P1, then then add something to the path, and then we compute P2, which will be carried over to the next iteration. Right, I like this. Now, can I make this one line? No. So now we will have we want to draw a curve, a cubic Bezier curve. The command is a letter C. And we want the first control point, so this one right here, that would be P2 from the previous iteration. So let's say that this is P2 from the previous iteration. And then the control point for this, and this is P1 from the current iteration. So it's the P1 we have just computed. And then we want to put x1 here. Okay, moment of the truth. We will try this out. Place your bets. Do you think that it's not going to draw anything? There is just a bug. Do you think that it's going to draw something that is smooth and nice? Or do you think that it will be all over the place? I mean, it will not be a bunch of straight lines. That much we know, I think. I mean, it shouldn't be. Let's try this. And the answer is, it doesn't draw anything. Excellent, we have a bug. Let us draw just a little bit and we'll look at the SVG that was generated. Oh, I think I already know a mistake. So before we even do that, maybe that's the mistake. Spaces could be a mistake, or commas could be a mistake, like this, yeah. Yeah, so that comma could be the problem. Let's try this again. No, it doesn't draw anything. So we can open the developer tools and we can take a peek at the SVG. The SVG is empty. Now that is something. Drawing is not defined, there her message says. What? I think I commented out too much. Oh, look at that. We have a drawing that is smooth. If I do it like this, I mean, it is not 100%, it's not perfect, but it is more like a circle than it was before. And sometimes there are these little squiggles, and I don't know why. Maybe the events, the points that we have to work with are maybe we could have floating point problems because these are all floating point numbers, but I don't think that's the case. I think that the precision is good enough for the kind of work we are doing. I mean, the precision of floating points is good enough for the kind of thing we are doing. So I don't think it's that. It could be that the events fire inconsistently, like too much to the left or to the right, but I don't think that's the case. It's probably something about literally the algorithm we are using to smooth things out. But I'm kind of okay with the result. Now the eraser doesn't work. Let me try to write something. So there is a factor that is, I am new to drawing on a tablet in general. Oh, and look at that. It stops drawing at some point. Sometimes it stops drawing right away, sometimes it stops drawing after a little bit, but it stops. Huh, that's a bug. But the feeling of writing, I wrote this and the feeling was good. I mean, I'm new to the tablet, so I don't expect my handwriting to be all that good, and it's not even good in real life. But it felt okay. I mean, it feels like the kind of drawing app that is for explaining stuff on a stream. It's not the drawing app that you would use to draw, really. I mean, if you are a cartoonist, like, you wouldn't use this. But that's okay. So I wonder why it stops drawing. I mean, one thing we can do is just try to reproduce the problem with a small case. Oh, that's a very good small case. So the problem has occurred, and we can look at the console and see what is going on there. Oh, so we are getting some not a numbers there. So there is that. Also, does the path look reasonable? It does to me. Looks okay. But then there are all these not a numbers in the middle. Yeah, so that's what I was thinking. The reason, so David says, oh, by the way, hi David. You were here with me yesterday doing the first part of this, and I'm glad that you were here to see the thing coming along. So yeah, one of the reasons why you might end up with not a number is because you're trying to divide by 0. So let's look at all the divisions we do, which I think there are only these two divisions, but there is also this. So the square root, that's not an issue. The square root of negative numbers, I think, is not a number. Let's check. So the math square root of -1 is not a number, but I don't think that's an issue because we are squaring all the terms, so they are going to be non-negative. That's fine. So David, what do you think of the backdrop? Do you like the backdrop, or do you prefer the other version with just my office behind me? I'm experimenting with the backdrop. I'm trying to see if I like it. So the square root will never be negative. That's fine. And additions are always okay. They don't produce not a number. Oh, so David likes the backdrop. Great. I mean, it kind of feels like the kind of picture you would take for prom when you're in high school. You know what I mean? But it's okay. I'm trying it out. Another thing I could try is to just try to get one of those green backdrops, and I could do a chroma key and put myself on top of the screen, which is like the coding train, which is one of my inspirations for this channel. The coding train does that, but it's kind of doesn't. I mean, it's nice, it's fun. You can point at stuff in the screen, but okay. So division by 0 is a problem. So can this ever be 0? Well, if the points are too close together, this could be 0. So how about we alert when this is 0? Yeah, so David's saying that this is my issue. Let's see. I want to see it with my own eyes. There you go, that was 0. So that's weird. I thought that JavaScript would not fire events. JavaScript would not fire events if the mouse didn't move, but it seems like if I just hold my cursor in place, it keeps firing the events. I don't know, let's see. So I put my cursor down and I don't move. So it doesn't fire mouse move events. And then I move just a bit and it fires a bunch of mouse move events, some of which may be for the same point. So we could maybe compare. So if x1x is equal to x2x, and y is also the same, so in other words they are the same point, just return. Stop executing this function, leave it for next time. That is not going to advance x1 and x0, but it is going to advance x2. So how about we do it even before? Let's check event versus x2. No, against x1. I mean, that amounts to the same. Oh, and x2 was not one of those global variables we keep throwing around. But I kind of like it. I think I prefer it to be one of those. I mean, not because we need it to be, we just saw that that's not necessary, but conceptually it makes sense to have all these points here. I think that we don't explicitly need P2 either. No, we don't explicitly need P1 to be a global like this either. Because we compute it, we compute P1, and then we use it, but the next time we go around, we will compute it again. So we are not actually using P1, it could be a local variable. But that's a special case, so I'll leave everything as a kind of a global. So, okay, we are checking now against x2. So the first thing we do is we check, do I have a point that is different? If so, then proceed. Otherwise, don't do anything. Pretend that this event didn't even fire. And just by virtue of doing this comparison, I am sure that the points will not be the same from this point in the code forward. And if the points are not the same, the distance will not be 0. Theoretically. Okay, so David is saying remove all duped points. That's exactly what I'm doing. Or return same control point. No, I am ignoring events if the cursor didn't move. That's what I'm doing. Okay, I think we fixed it. Also, conceptually, I like this better because we don't want to... I'm just doodling. We don't want to have a bunch of Bezier curves for the same point. Doesn't make sense. I didn't know that JavaScript would behave this way. So let's try to write something and see if it feels natural. Oh, I hate when people write JavaScript with a lowercase s. So this is kind of nice to write. I mean, I feel okay drawing all this. Let's play with different smoothness factors. Where is our friend, the letter T? It's here. I guess this can also be a constant up here. Doesn't need to be defined on every mouse move. So we have a smoothing factor of 0 should give us straight lines. So we are back to where we started. A smoothness factor of like 5 will be crazy because it will create all these sorts of loops because the control points will be too far away from the point on the line. Let's see how this looks. Ooh, nice. It kind of looks like a crazy line. You can see all the loops when I go too fast. So the problem here is that there could be a point like here, for instance, I think is a point. But the control points for this point are so far that they actually make a loop. So it would start with something like a curve, like the one I am drawing, but not really, because if I try to, I think it would be crazy. Let's see. Yeah, so it would start with a curve like this, but then a curve that is very sharp would be like this. A curve that is less sharp would be like this. But if you take the curviness of the curve too far, you have to loop around in order to be able to do that. So a smoothness factor that is too high, I think even the number 1 is probably too much. Yeah, it starts to look, it's kind of weird. It is curvy, but it's curvy on the other direction. So the curve we want is like this. And the curve, I mean, I probably should zoom in. The curve we want goes like this. And the curve we have goes like this. So it's inverted. So a smoothness factor of 1 is also too big. And in the document we are referring to, they suggest something like 0.5, maybe 0.25, maybe 0.3, something along those lines. 0.5 is okay. I am not in love with what it does if I am moving too slowly, but I'm not sure that this has to do with the smoothness factor. I mean, we had the same problem before. But 0.5 is acceptable. How about this? How about we are going to put on the menu something that changes the smoothness factor, and then we can play around interactively, and we can change it and draw other curves, and then we will be able to tell the difference visually with everything on the screen at the same time. So let's review the changes, and then we can commit what we have, and then we'll do the thing I just explained, and add T to the menu. We may want to remove it later, but we want to experiment with it, so that's what we're gonna do. So I guess we are safe to remove all these comments, because at this point we have copy and pasted everything we care about. Okay. How does this look? Yeah, sounds good. And then over here, I mean, look at this algorithm. It's not long. It's great. Yeah, fun stuff. Okay, committing what I have, and let's go to the menu and add a smoothness factor real quick. So let's add a label that we will call smoothness, and I will use an input of type range. That's the nice thing about developing for Electron as opposed to developing for the web. For the web, it's hard to style, and it's not supported across browsers, this kind of type of input, but we are only targeting Chromium or Google Chrome because we are in Electron. So bam, that works. And the name of this will be T, I suppose. And I don't remember all the parameters because I usually develop for the web. I am not able to use these kinds of inputs. So I'll go to the docs real quick. Okay, so type range, ID, name, and minimum and maximum. So how about we let this go from 0 up to 5, whatever. And then we have a notion of step. What is the default step? On this first example, they don't have a step. Oh, but they also don't show the number. So that's brilliant. The default is 1. So we want this to be a step of about 0, 1. That sounds good. Let's see how this looks on the menu. So it doesn't look good, but I can move it around, and it's not going in big jumps, so it seems to be using 0.1 as the step size. Now, I would like this to occupy just the screen that we currently have. I could change the screen size, but I probably can also just say style width 100%. There you go. So now the smoothness is in this area. And I would love to see the number, because I will have to maybe put this number somewhere. So I would love to be able to see the number. So I'll have here an on change that looks at this, and then next element sibling dot, I think it is text content. I think that's what it is. And then this value. Doesn't show. Oh, it does show. Oh, but it only shows when I leave the cursor. but that's fine. How about we start with a value of 0.5. I mean, I think that's what it does, right? I mean, let's take out this line and see where the handle starts. It starts in the middle. Okay, so what is the default value? Well, I would like this function to run when you load the document, because I would like this to be populated with the default value. You know what? I think what I can do is just say value of 0.5, and here I can say 0.5 and I hard code the full value. That works. So now we have this lovely number to work with. All we have to do is on our handle mouse move, T here will be well, I don't need to do anything with T. I can just look at all the places where it is used. These 4 places, I can go there and I can change the occurrences of T to read like menu.t, which makes the T variable unused, I think. Yep. And now we have something that is reasonable, we have something outrageous, and we can play around. Something that is square. .5 is a good one. 0.5 is okay. 1, I think we know that 1 is too much. How about 0.75? 0.75 doesn't look as good as this. I should be more methodical about this. Let's see. So this is 0. This is 0.5. I'm gonna go to 0.25. I mean, and I'm not able to go to 0.25 because my steps are 0.1, but I will go to 0.2. 0.2. 0.2 is kind of okay. It's kind of squarish over here, but it's not bad. 0.2 I like. How about 0.5? Whatever, 0.6. Which one do you like better, 0.2 or 0.6? They're kind of equivalent. I think that we probably want something in between. So maybe, I mean, let's just make sure that 0.7 is not good. So let's go to 0.7. Yeah, 0.7 is already too much. It's starting to look like straight lines because it's going to start bending the other way. So 0.7 is too much. 0.6 kind of acceptable. 0.2 I still think looks better. 0.4 we didn't try, so let's try 0.4. Okay, 0.4 is good. I think that 0.3 or 0.4 might be our guys. Oh, now I wish I made this slider bigger. There you go. Okay, let's make a decision. 0.2 is fine. 0.7, okay, I will get a marker that is thick and that is red. And I will say that 0 is a no-go. 0.2 is kind of okay. I'll leave that in blue. It's not my favorite. Then 0.7 is crap. Oh, you know what I'm thinking? Maybe we should make the marker always put lines before the elements, so the marker will render below the rest of the drawing. Yeah, that could be kind of fun. I'll probably forget this at some point and then I will remember it again. So let's come back here and see. So 0.3 versus 0.5, let's say. Which one do I like better? I like 0.3. I mean, look at this O and look at this O. Just in general, these don't look as good. So 0.3 is winning. How about between 0.2 and 0.3? I mean, also look at this O, and this part here doesn't look very smooth. So yeah, I'm gonna stay with 0.3. And what else? 0.3 versus 0.6. Oh, I don't like this one. Yeah. 6 is too much. How about 0.4? The difference is very small. But I think I prefer 0.4. And I don't think it makes sense for us to let the user customize this. I mean, the difference is very small, and when you go too far apart, you start drawing stuff that just doesn't make sense. It looks bad. So we will hard code 0.4. That's what we are gonna do. Let's see what I changed here. I introduced that and I introduced this, and I don't care about either of these changes. I want to hard code 0.4. That's our magic value. Okay, I feel good about this. Let's do the thing that I mentioned and put all the markers below the things you draw. So I guess I'll do it again for motivation. So if you draw something and then you try to use the marker, it marks on top off. You can see that the black is below. The black here is below. But I would like the marker to always be below everything else you draw. Oh, we also need to fix the eraser. That's for the future. So let's do something that goes like this. We will have SVG groups. We'll have two of them. One is markers, and the other is pens. Tá bom. So now we are going to insert if you are using the pen or if you're using the marker, we will do different things. We will not just insert into the drawing. We are going to insert into the drawing.query selector. Also, how about we make this be the name of the tool? This way we can say that we want to select the class that is dot and then menu tool. And then we can draw something in black. No, we cannot. What's going on? Oh, it's trying to append to G and okay, I think I know what's going on. The way we are getting this path is by saying drawing last element child, which in this case is this group, and it doesn't make sense. So instead, what we need to do is I'll call this the group, and I will use group, insert adjacent HTML, and then group last element child. So we draw something, we are able to draw. We put the marker in green, and we use the marker, and it is below the drawing. Yep, I prefer it like this. This change stays. What is next? You know, something I would like to do, it's a feature that I saw with David actually in a competitor, and it seems like you are also able to draw on top of your screen using Zoom. So I think that Zoom also implements this. I just noticed that my microphone was too quiet. Is that better for you? Let me know if that's better for you. Okay, so there is this feature that some of these drawing apps have, that is, when you draw something, it stays on the screen just for a while and then it goes away. And I think it could be kind of nice to do it, to do this ourselves, and we could use CSS to do that. So let's do it. So here, when I am drawing, I have the handle mouse move event, but I want to now have an extra thing which will be on mouse up, because I will want to add this transition when you take out the mouse. So when you're drawing, the line doesn't go away in the middle of your drawing. When you're drawing, the line stays there and then it goes away after you leave, or when you take out the cursor from the tablet. So I will need not only handle mouse move, but I will also need handle mouse up. And how does that work? Okay, so I guess I will have a default handle mouse up, because usually in other tools we may not want to have on mouse up. I guess I can also leave it like this. So handle mouse up will be a variable that we declare here in the beginning, and then in the different tools we assign different mouse move, mouse up events. We assign different mouse up events that you may care about, and then at the end we call that function if it has been defined. Where is my code? It is here. So now we can check at the end here. Do we want to run that before or after we unassign the other event? I don't think it matters. So do it like this, after. So handle mouse up is not undefined, then handle mouse up. And Then here on the pen and the marker, I have defined my lovely little handle mouse move, and right after that I will say handle mouse up is a function that, what does it do? Let's start with something simple. It sets the opacity to 0, so we won't be able to see the shape anymore. So let's just do a path.style.opacity equals 0. I draw something and then I let go and it goes away. Now let's do this with a transition. So when I add a path, I will have a style that says transition opacity in... That's maybe something we want to present to the user, but I'm going to start with half a second. Alternatively, 500 milliseconds. I don't think that works though. Let's try this. I think it will still disappear immediately. So I draw something, let go. Oh no, that works. Awesome. And maybe we want some sort of special curve on this transition. So here is a trick. I can open a new buffer in Visual Studio Code and go to CSS, change the mode of the file to CSS. And then I can do something like whatever, body, and then transition. Why am I doing all this? You may wonder. Because of this autocomplete. So these are Bezier functions. They happen to also be cubic Bezier functions, but they have nothing to do with the cubic Bezier functions we are using to draw. They have to do with the speed of the animation. So it may be slow in the beginning and then fast and that kind of thing. So I don't really know what these parameters look like. So I guess I'll just take one of these and try it. And it goes as a third argument to the transition. So let's try this one. Yeah, that one is, will hang on for a little while and then immediately go to transparent. Oh, there are these other options. How about ease in or ease out? I don't know which of the two I want, but I want it to be hanging on the screen for a while and then go away. So I'm not sure if it's ease in or ease out that I want, but I'll try. Oh, that's good. So it hangs on for just a little bit and then it goes away. And I suppose if I make this more extreme, then it will be clearer that this is what's going on. So I draw something, let go. Yep, it starts to fade slowly and then goes fast. There is this great line in a book by one of my favorite authors, John Green, and I'm not sure that the line is his, but it's in his book. It's there. Maybe he copied from somewhere. And he says that she fell in love the way you fall asleep. Slowly at first, but then all at once. Which is exactly how we are fading out the lines on our drawing app. Okay. So I think that this duration is something we may want to present to the user. And we'll probably have like 2 or 3 options, maybe fast, medium, and slow. Oh, and another thing that I think would be kind of nice is after the transition is over, it could be kind of nice for us to remove that element. Which one do I want to do first? I mean, I'm tempted to try to remove the SVG from the drawing just because I don't know how to do that. And I do know how to put stuff on the menu. We just did that in this stream. So I know that there is a way for you to handle this in JavaScript, CSS, transition, and something like this. I think there is an event that I can listen to that will tell me if the transition is over. And I think that may be it. So how about we say path on, maybe add event listener, why not? And then we will do transition end. And then here we will alert ended. I draw something, it goes away, and then I see the alert. Awesome. So instead of doing that, how about we say path remove, which literally removes the SVG from the DOM. Fun stuff. So in order to see that this is working, I will open developer tools, not on the menu though. Let's try this again. I will open the developer tools and keep an eye on the SVG, specifically on the pen stuff. Oh my god. So yeah, it is working because I draw something. You can see over there, I cannot point at it because I have my cursor in place, but you can see that there is a small triangle, a disclosure triangle, which means that there is a child here, which is our drawing. But then when I leave and I let go, you can see that now it is, it doesn't have a disclosure triangle. So it is removing the elements from the DOM correctly. Cool. I don't think I need this buffer anymore. Let's add some options to the menu. And this will be the fade. Yeah. Fade duration. Fade. Value false. And I don't need this on change stuff. So doesn't fade. How about we just say something like p fade, and then we have none for false, and then we'll have fast, or maybe the other way around. So slow, which will be maybe that much. We'll have medium, which will be maybe that much, and we'll have a fast, which could be 500 milliseconds. And let's see how that looks on the menu. Non, slow, fast, and medium. So I want this to not be a paragraph because of the margins. I'm happy to have this as a div or a spam. It doesn't really matter. And then here I will have to say that this is chat. So to begin with, it doesn't fade away. Yeah, I'm okay with that. And then we will look at the fade. I guess I can just put the fade here. So I'll say menu fade. Oh, but I need to do that in terms of milliseconds. So there you go. And here below, I will check if menu fade equals false, then return, because I don't want to fade. So I can draw and it doesn't go away. Now it will go away but slowly. And now it will go away but medium. And now it will go away but fast. Okay, I'm happy. Let's commit this. And then if the fade is false, which is one of the options on the menu, right? Yeah, if the fade is false, then we put a CSS that doesn't make sense here, but it's fine because it will be ignored. Do you want to check for this? I guess I will, just for correctness. So I'll check, is the menu fade equals to false? If so, don't add anything to the styles. Otherwise, oh, come on, not like that. If so, don't add anything to the styles. Otherwise, add this. So we don't end up with nonsensical CSS. That's fine. Let's see if it still works. I mean, it should, but you never know. Alrighty. And then we will see if everything makes sense, and we will wrap it up for today. Okay, so handle mouse up, which we are calling from there. And then over here we have a style that is conditional on whether we want to fade or not. If we want to fade, we fade the opacity. Over here we have a handle mouse up that is, if I am not fading, don't do anything, but if I am fading, then set the opacity to 0, and after everything is done, remove the thing from the DOM. Alrighty. And what do we have on the menu? So we have fade and a bunch of inputs from none to slow to medium to fast. And just like that, bam, just like that, the drawing app now has all these other features that it didn't have before. And let's recap. Today we moved further with the smoothing of the lines. So now we fully implemented the algorithm from yesterday. Yesterday we did just 3 points, and today we are doing more points. Also, we played around with the smoothness, so we had to implement some auxiliary code that allowed us to play around with the smoothness, so we would find a smoothness that would satisfy us, or at least that would satisfy me. Then we implemented the fading out. And I think that's what we did today. So yeah, thank you all for being here. I see you tomorrow at 5:30 UTC. Thank you for subscribing, for supporting me on PayPal and Patreon. Thank you for being awesome all around. And yeah, that's it. Enjoy. Have a good one. See you tomorrow. Thanks for being here. Bye.